All right, guys, here's a quick lesson on how to divide radicals. So first, if you remember, we can divide outside numbers and we can divide inside numbers separately, just like when we added. So if you come across a problem that has things that you can obviously simplify, you can do 12 divided by 2 is 6, and then you can divide what's inside the radical. If you do 160 divided by 5, you get 32. Then we always need to check, can you reduce your answer? So remember, we can rewrite this as the square root of 16 times the square root of 2. Remember, this is 4. If you have a number outside, you multiply, so this ends up being 24 radical 2. So that's the first example off of your note packet. If you look at number 2, even if you come across a question that's a cube, or this is a fourth actually. So again, can you divide outside numbers? Yes, so 36 divided by 9 is 4. Can you do 1250 divided by 2? Yep, that's 625. And if you look at our list of perfect fourths, this is actually a perfect fourth. This is 5 times 5 times 5 times 5. So this actually ends up being just 20. Remember, you don't have to have a radical left over. If you remember the rule, if when multiplying you add your exponents, then if you're dividing, you're going to subtract your exponents. So most of the cases, you're going to end up with more x's and y's on top versus bottom. And all you're going to do is subtract and then possibly simplify. So in this case, I have 3 on top and 2 on bottom, which means I have 1 left on top. Now, actually, I'm going to ignore that. But again, we didn't take this out of a square root yet. And then I have 9 on top and 5 on bottom. So if I subtract those, I have 4. Now, can I reduce this? Remember, I talked about pairs of socks. If I have 1 sock, I can't take out a pair. But if I have 4 pair of socks, I can take out 2 pair and have 1 left. Now, don't stress over the ones with variables. Honestly, whenever we end up taking the test over this, I think there might only be 2 total questions on the whole thing that have a variable. So don't freak out if you're struggling with those. So same thing with, so number 5. So that some problems are nice and pretty, and the fact that we can actually completely reduce them. So the first thing you should check before you start taking the square root of the top and the square root of the bottom like we previously did is, can you reduce the numbers inside? So if both of these are inside the radical, can you do 48 divided by 16? The answer is yes. That's just 3. Now, we didn't do anything with our square root yet, so this is just our answer. There's no way to reduce this because this is a prime number. If you look at number 6, okay, so I don't know if I look at my perfect cube list. Step 1, I can't reduce 40 over 27. Step 2 is 40 or 27 a perfect cube? Well, in this case, 40 is not, so I'm going to rewrite that as the square root of 40, or cube root of 40, my bad. But the cube root of 27 is simply just 3. But then you, again, just like usual, you need to double check, can you reduce the cube root of 40? So then go to your perfect cube list, and again, this is on the front page of your note packet. Do I have a cube that goes into 40? And the answer is yes, 8. So I can rewrite the top as the cube root of 8 times the cube root of 5. Well, the cube root of 8 is just 2, so that goes to the front. But in general, our overall rule is you are not allowed to leave a radical in the denominator. Since this is simplified, this is my case. Now, in general, and I'll talk about this in a second, if you're reducing within a fraction, you can only reduce outside numbers or inside numbers. I couldn't combine these guys. So there are questions such as starting with number 9 in which you have to rationalize the denominator. So we actually already did a similar topic to this when we did imaginary numbers and we talked about I. So if we're talking about I, you weren't allowed to leave an I in the denominator. Well, same concept, you're not allowed to leave a radical in the denominator. But to get rid of it, if you remembered when we had a previous question and we would multiply by I on top and bottom, same concept, I'm going to multiply by radical 5 on top and bottom. So remember our little trick that we talked about on Friday. So the top would be outside number times inside number, just become attached. But remember, radical 5 times radical 5 is really radical 25, and radical 25 is just 5. So this is really the same as 2 times 5, which gives me 10. So again, when I just mentioned simplifying, if I can't reduce 3 over 10, then my answer is done. I can't reduce an inside number with an outside number. That's not allowed. So this is my final answer. So then if you look at number 10, so I have 8 over 15. Okay, so first check, can you reduce 8 over 15? No. Well, then remember, we can rewrite this as the square root of 8 over the square root of 15. Those two things are equivalent. And then I'm going to multiply by 15 on top and bottom. Now, I actually got a calculator out. 8 times 15 is 120. But then, radical 15 times radical 15, which is regular old 15. Okay, but then, as usual, we got to check to see if we can reduce 40. And the answer is yes, we definitely can. Shockingly enough, the largest perfect square that goes into it is 4. So the square root of 4 is 2, so it goes to the front. 30 is left over, and the whole thing is over 15. And again, this is simplified. Even though you'd think you could reduce these, you can't, because one's an inside number and one's an outside number. Okay, moving to the back of the paper. Okay, so far, not too crazy. We can do most of these questions. Not that difficult. If you look at number 11, so I got 3 radical 12 over 4 radical 7. Now, you could try to reduce these ahead of time, but more than likely, you're just going to have to reduce again. So you might as well just try to rationalize the denominator first. So again, not allowed to have a radical in the denominator. Now, it doesn't matter if it has a number in front of it. You only have to multiply by the radical. So I'm going to multiply by radical 7 over radical 7. If you were to multiply by 4 radical 7, you would get the same answer. You would just have to do more simplifying. So again, top, outside number times outside number. So the top is 3. 12 times 7 is 84. The bottom, remember, radical 7 times radical 7 is just 7, and 7 times 4 is 28. Okay, then again, like usual, we're going to have to try to reduce. So do I know of a perfect square that goes into 84? I think it might even just be 4. Oops. Yep, it's just 4. So this is 4 times 21. This is 2. Okay, once you have your radical simplified, then you're going to make sure you can't reduce this. Well, obviously I can reduce 6 over 28. Remember, don't ignore the inner number because we can't do anything with that. But I can reduce the outside numbers. So 6 over 28 can reduce to 3 over 14. And again, even though it seems like you should be able to reduce these, but I divide by 7, you are not allowed to divide an inside number with an outside number. All right, then we get to problems in which you have a binomial either on the top or on the bottom. Now don't get scared, they're actually not that difficult. So again, if I have a radical in the denominator, I'm going to multiply by that on top and bottom. The only difference is I have a binomial, so I'm going to have to distribute backwards, so double rainbow. So radical 8 times radical 2 is radical 16. Radical 2 times radical 2 is radical 4. And then remember my trick is, what's radical 2 times radical 2? It's just 2. However, both of these guys are perfect squares. This is really 8 minus 2 over 2. Well, 8 minus 2 is 6. 6 divided by 2 is simply just 3. That one actually turned out really nice. Most of them do not. But then, if you look at 15, and you've glanced at the notes already filled out on Classroom, we come across problems like this guy, where you have what we call a binomial, and you're going to have to use its conjugate. So you're going to multiply by the conjugate. So we did, again, these questions when we talked about I. So we did, if it was like 4 plus I, you multiply by 4 minus I. So if it's 4 plus radical 2, I'm going to multiply by 4 minus radical 2. Now again, what's your gut instinct tell you to do on the top? So I'm going to distribute on the top. So it's going to be 16 minus 4 radical 2. But then my denominator is always going to end up being a squared minus b squared. So denominator, my little trick is a squared minus b squared, which you could FOIL these out and get the same answer, because I'll just show you why it works out that way. So if I FOIL this, 4 times 4 is 16. 4 times negative radical 2 is negative 4 radical 2. This would be a positive 4 radical 2. And this radical 2 times radical 2 would be minus 2. Then these guys cancel. 16 minus 2 is 14. Okay, now, this answer actually can be reduced if I reduce. Okay, because this is a binomial, or is multiplication, or addition and subtraction, my bad. If all of the outside numbers can be reduced by the same thing, you can simplify your answer. So I can divide all of these by 2. Okay, that does not affect the radical. That just affects your final answer. So that's my final answer for number 15. All right, then again, if you want another answer with the binomial, so I've got 16. Okay, so again, I got a binomial as my denominator, so I'm going to need to multiply it by its complex, or by its conjugate. So 6 plus radical 5. So I can distribute on the top. And then I'm going to use my little trick for the denominator. Now you could FOIL these out if you want. More power to you. Remember, your trick is a squared minus b squared. So 6 times 6 is 36. It's always subtraction. Radical 5 times radical 5 is just simply 5. And then again, I can't reduce this because 12, 2, and 31 cannot be reduced by the same number. Okay, almost done, I promise. Then if you look, well, actually, I think in the homework packet, I think I might have gotten rid of some of these. Oh, I think that's all the farther we need to go, because if you remember in your homework packet, if you were paying attention on Friday, or if you were here on Friday, I said for you to just go to number 16. We were crossing out 17 and we were crossing out 18. And again, that is all in reference to worksheet 6.3. Okay, so that's your little mini lesson. If anybody has any questions or you have responses to this, please let me know. Good luck, guys.